Hello and welcome again as we look at yet another multiple choice question for IB chemistry. And this particular question is dealing with topic 10 of the syllabus, but it can be connected to so many other areas. And like I always advise students, when you're using these multiple choice questions to get ready for exams, it's important not just to arrive at the answer, but to reflect on what alternate questions can be created from this one, and also to reflect on all of the relevant topics that this question might be able to connect to in the IB chemistry guide. So let's take this question and look at it from that perspective. So first of all, with the question, which alcohols are oxidized by acidified potassium dichromate 6 solution? Well, we could go into a discussion as to what is oxidation, what is reduction, why they have this Roman 6 here. When oxidation happens, what happens to the dichromate? The dichromate, of course, is reduced because it is the oxidizing agent, and its oxidation state goes from 6, which is what it is here, and it becomes chromium 3. When that happens, the color of the dichromate changes from an orange color to a green color. Why does that color change happen? What is the reason for that color change? What are the changes in oxidation number? What's oxidized? What's reduced? All of those things connect to other parts of the chemistry guide. But for this specific question, how you could arrive at the answer is simply by memorizing that primary and secondary alcohols are the only ones that can undergo oxidation. So when you treat these three alcohols here with an oxidizing agent, which is acidified potassium dichromate, only primary alcohols and secondary alcohols will be oxidized. Tertiary alcohols cannot be oxidized. If you want to go back over the classification of alcohols, click on this card above. And if you want to learn more about the oxidation of alcohols, click on this one. But for this particular question, if you did memorize that a primary alcohol can be oxidized, a secondary alcohol can be oxidized, but a tertiary can't, then you still have an issue, because you need to look at this list and say, well, which one is primary, which one's secondary, and which one is tertiary? Now let's do that. And here you can see in this first one, the OH functional group of the alcohol is attached here to a carbon, and here of course they use this type of notation where the two H's are not separated, but this OH is attached to a carbon, which in turn is attached to two other hydrogens. That makes this a primary alcohol. Here we have a secondary alcohol because the OH functional group is attached to a carbon that is in turn attached to one other hydrogen and two carbons on either side. But here we have a tertiary alcohol because the functional group, the OH, is attached to a carbon which is in turn attached to three other carbons, primary alcohol and secondary alcohol. When the primary alcohol is treated with this oxidizing agent, initially it produces an aldehyde. Of course, that's not required in this question, but you should know that upon further oxidation, it would produce a carboxylic acid. For a secondary alcohol, you're only going to get a ketone, and for a tertiary alcohol, it cannot be oxidized. On the topic of converting alcohols to ketones, aldehydes, and carboxylic acids by oxidation, you should also reflect on when you get the carboxylic acid, when you get the aldehyde, and when you get the ketone, what conditions are needed to reverse the process. And one way to reverse these oxidations, in other words, to carry out reduction, is to heat the acids or the aldehydes or the ketones with lithium aluminium hydride in a solvent like ether. But the answer to this question, of course, is because this is a primary alcohol and this is a secondary alcohol, 1 and 2 are correct. Answer to this question is A.